All right, welcome back. Now, let's take a look at this example here. We've got three functions here. So let's analyze each of them and see whether they're even or odd. Okay, so the first thing I'm going to do is I'm going to take f of negative x, right? So f of negative x is going to give me what? Negative 2 times negative x to the fourth power plus 5 times the absolute value of negative x. Okay, now, if I simplify this, what happens? So here, again, I'm not going to go through the algebra, but if you notice, this is negative x raised to the fourth power. So we know that this is going to be negative 1 raised to the fourth power, and since it's an even power, the negative is going to turn positive, right? Because a negative times a negative is always positive, and so an even number is always going, an even exponent is always going to give us positive here. And also the absolute value of a negative number is always going to be positive. So again, this is going to give us positive, and this is going to give us positive. So we're going to get negative 2 x to the fourth plus 5 times the absolute value of x, which is what we started with. Okay? So this is an even function. Okay? Now, so it's an even function. Now, I didn't get the opposite, right? So I didn't get the negative of f of x. So it's not odd. So it's even function. Okay? So there we go. Okay? Now, what about g of x? Well, let's do g of negative x. Okay? So that's going to give us 4 times negative x to the third power minus negative x. All right. So let's see what happens with this one. Now, this one here is going to be negative x to the third power. So because this here is an odd exponent, we know we're going to end up with a negative 1. So here, what's going to happen is we're going to end up with a negative 1 on the outside, right? So negative 1 times 4x cubed, right? Because we're going to get negative 1 cubed, which is negative 1, and then we're going to end up with x cubed. And then we have our 4. And then, of course, here, the negative is going to come out, and we're going to get a minus, and I'm going to leave the negative 1 here for a moment. Okay, negative 1x. Now, notice I've got this negative 1, this negative 1 here, and this negative 1 here, which means I can factor it out. So I get negative 1 times what? 4x cubed minus x, which is what? It's the negative of g of x. So in this case, g of negative x equals the negative of g of x, which means that this is an odd function. All right, cool. So A is even, and part B is odd. Now what about this one? What about h of x? So let's look at h of x. So let's do h of negative x. And so that's going to give us 2 times negative x to the second power plus negative x. Now in this case here, again, this raised to the even power here is going to give us 2x, right? Because negative 1 times negative 1 is positive 1. So that's going to give us 2x. This is just it's going to give us what? It's going to bring out the negative 1, so that's going to make that a subtraction. Okay, so now in this case, if we pull out a negative 1, we're not going to get the negative of h of x. but we don't get the original function back either. So this would be neither odd nor even. Okay? So now this brings up something interesting that you may or may not have noticed, right? So in this case here, what were we dealing with? We're dealing with even exponents or absolute value. And when we're dealing with exponents that are even, so we got variables with even exponents, or we've got variables that are dealing with absolute value, those will always give us a positive outcome. So if we replace these with negative values, they will always end up being positive. So in the case that we have a function where all the exponents of the variables are even or absolute value, then we're going to end up getting an even function. Those will always be even functions. Okay. Also, look at this one. We have exponents that are all odd. And so what we know about variables with odd exponents, that if they're negative, we will always get a negative or opposite value. Okay? So if I put in a negative here, I'm going to get a negative out. If I put a negative here, I'm going to get a negative out. So that means that anytime I have a function where all of the variables are odd, or all the exponents are odd, right? Like in this case here, I'm going to get an odd function. Okay? Now, here I have a mixture of even and odd exponents. So in this case here, it ended up being neither. So one thing to look at is, if you want to kind of put absolute values off to the side for a moment, is look at the exponents of the function, right? So if the variables have all even exponents, right? So you have a polynomial function, right? And all of the exponents on the variables are all even. So in other words, all the terms have a degree, even degree. Well, if you don't understand that, that's fine. But if all of the exponents on the variables are even, then you have an even function. If all of the exponents of the variables are odd, then that will tell you you have an odd function. If you have a mixture of even and odd exponents when it comes to the variables, then you're going to have neither odd nor even, okay? And then of course, including the absolute value, which is always positive too, that'll be even. All right. Hopefully that all made sense. And again, practice with this stuff and ask questions. Have a great day.